Okay, good morning guys. This is the next session in physics. So today we'll just discuss adding vectors, okay? And this topic is a little bit difficult for most of the students, and also it's very important in physics. Why it's important in physics? Because most of the physical quantities are vector quantities. So how to add these vector quantities, this is very important. Vectors. How can we add vectors? We don't add vectors by the same way. So what does it mean? It means, for example, not all vectors the same. Okay, we have different. For example, if I have vectors, okay, on the same axis, we add them by a certain way. If we have vectors perpendicular to each other, so we add them by a different way. So let's start with this point. Adding vectors on the same axis or adding parallel vectors. Adding parallel vectors. Adding parallel vectors actually means if the vectors on the same axis means all the vectors on x-axis or all the vectors on y-axis. Okay, for example, let's say there is a force, there is an object, and we have here two forces to the right. The first one is called F1 and the second one is called F2, and F1 and F2 in this direction, this is 10 for example, 10 Newton, and this is 5 Newton. Okay? So actually to add these two forces, they are in the same direction, so we just add them simply by this way. 10 plus 5 equal 15. So it will be 15. So this one is 15 Newton. Okay? Why I use here force? Because force is just a vector. So maybe force, maybe field, maybe velocity, maybe displacement, maybe anything, any vector quantity. If there is another case which the two vectors in opposite direction, so simply for example, if this is 10 Newton and we have another one to the left is 7 Newton, so when we just add them, the two vectors, okay, so this 10 to the right, so it will be positive, this 7 to the left, so it will be negative. So actually this will be positive, this will be negative. So when we add them, so the resultant will be 3, and the 3 means to the right, so it will be 3. So the point here, okay, just never give two opposite direction the same sign in vectors. So if I take right as a positive, so you have to take left as a negative. The second case, if the two vectors are perpendicular to each other. Perpendicular to each other means the two vectors on x or the two vectors, perpendicular means one vector on x-axis and the other one on y-axis. For example, the same object, and we have here a force, and this force, for example, is 3 Newton, and we have another force, push this one 4 by 4 Newton. So if I ask about the resultant vector, so the resultant vector will be, I take the first one as it is, 3, then the end of the first one will be the beginning for the second one. So the second one is 4, so just add, put it here. So this is the end for the first vector, this is the beginning for the second vector. So the resultant will be the straight line from the initial to the final. Where is the initial? This is the initial. Where is the final? This is the final. So this is straight line. Okay, this straight line is called the resultant vector. So how can we calculate this? This one can be calculated from Pythagorean theorem. So this is the hypotenuse. So this one I can get its magnitude by x squared plus y squared. What is x? X is the horizontal, which is 3 squared plus What is y? It's 4, so it will be 4 squared. So the resultant will be 5 in Newton, or 5 meter per second, or 5 meter per second squared. The unit depends on the type of the vector. Okay, what about the direction? To get the direction, in most cases we get the angle within x-axis. So if I know this angle, okay, I know the direction. So theta, which is the angle, is 10 to the power of negative 1. It will be opposite over adjacent. This is the opposite, which is 3. This is the adjacent, which is this is 4 divided by 3. So how can you do this in calculator? To be shift tan. To be shift tan 4 over 3, and you can figure out what is the angle exactly. Okay guys, so this is if the two forces are perpendicular to each other. One on x and the other one on y. Okay? I will give you an example about this. Say for example there is a dog. And this dog runs 4 meters or just 5 meters to the east, then 20 meters to the south. How can we have the two vectors? First, take the first one as it is. Where it is, this is to the right. So this is the east. So I take the east as 5. Then the end of the first one in the beginning for the second one. Never forget this. So this is the end for the first one. So the beginning for the second one, it will be 20 to the south. So this will be 20 to the south. So the straight line from the initial to the final. Okay, this is called the resultant vector. So in this case, by the same way, it will be 5 squared plus 20 squared. So when a dog runs 5 meters to the east, then 20 meters to the south, and he asks about find its displacement. Displacement, as we will study later, that the straight line from the initial to the final. Okay, so it will be 5 squared plus 20 squared, and you just figure it out. Okay, so when a dog runs 5 meters to the east, then it 20 meters to the south. So this is the 5 meter east, this is the 20 meter south. So he asked about what is the displacement. Displacement is the resultant vector. So this is the resultant vector. So how can we get the magnitude? The magnitude or the resultant R as a resultant equal the first one squared, x squared plus y squared. So it will be 5 squared plus 20 squared. Actually, it equals, this is 5 squared plus 20 squared equal 20.6, or it's almost 21. So this one equal to 21 meters. So this is the displacement. But how can we figure out what is the direction? So direction, as I told you here, so theta, first you have to figure out what is the angle. Tan to the power of negative 1, it's y over x. Okay, so theta, tan to the power of negative 1, y is 20, this is the vertical, x is 5. So shift, so it will be shift tan 20 over 5, 20 over 5 equal 76. So the angle will be 76 degrees. But this is not the direction, because in this case, the angle or your angle within x-axis. So this 76 may be in this direction within x, or in that direction, or here in the third quadrant, or in the fourth quadrant. It may be in any direction. So you have to tell me exactly in which quadrant. So if you look at this drawing, this is your initial point. So this is the first quadrant, this is the second quadrant, the third and the fourth. So you are actually in the fourth quadrant. Okay? So the point is you have two ways to describe this direction. The first way you can just say, okay, right is east, west, north and south. And my vector is between south and east. And its angle is 76 degrees. How can we read this angle? Okay, so it will be 76 south of east. South of east. So 76 south of east. Which means my angle is between south and east. And take care of this point. 76 within the east. So it looks like 76. I take 76 degrees from east to the south. So this is the point. Because if you use the other angle, it will be east of south. For example, if this angle is 76, so it will be 76 divided by 76 minus 90 equal, it's 14. So I can describe my direction also by this way. It will be 14 degrees. But instead of saying south of east, it will be east of south. So my angle is within the south, between the vector and the south. Here between the vector and the east. Okay, so this is about the direction.